Okay, so now it's recorded, right? So let's begin. So tonight we are going to do tutorial 1. So before we start, let's do some summary first. Okay, so I'm sure you can see my big screen here, right? So first of all, let's talk about this mutually exclusive events, right? Now, when we have two events A and B, we call them mutually exclusive. If what way? If one of the following happens, right? So what are the things here? So first of all, this is what we have. This is the first definition. All right, so A and B are mutually exclusive if A and B have no outcomes in common. Now, this definition also appears in our lecture notes. So in fact, this is what you get in the lecture notes. So when you say that two events A and B are mutually exclusive? Well, when these two events have no outcomes in common. All right. Now this one, A and B have no outcomes in common. Immediately, it will lead to this one here. All right. So A and B, the event A and B. A and B meaning that they both happen at the same time, right? So because they have no outcomes in common, so you actually get a null event. All right, null event. So that's why you see this empty set here. Is it okay? So this A and B, the N is represented by the intersection sign. So we say A and B is the null event. And this immediately will give us the third point. Now, if this one null event, right? Probability of A and B, then A and B is null event. Now, null event means that it will never happen. All right, so therefore the probability of null event is 0. All right, so that's why the second one actually means the third one. And then the third one also means something. Now, A and B. A and B means that the events A and B must happen at the same time. All right, must happen at the same time. So the probability of this is 0. So meaning what? Will A and B happen at the same time? So actually it's not. It's no. All right, so you see A and B cannot happen at the same time. So you see? So these are our 4, well, you can say that these are the 4 definitions. So A and B are called mutually exclusive if any one of these holds. Is it okay? All right, so the first line is actually our lecture notes, the definition. A and B got no outcomes in common. So no outcomes in common meaning what? Meaning that this event A and B, which is actually represented by this A intersect B, all right, although we don't say intersect. So this is actually a null event, okay? So this probability of null event is 0, all right? And because this one is a null event, never happens, right? So A and B never happens. So that means A and B cannot happen at the same time. All right, so this is mutually exclusive. Okay, so now let's go to the next point. So if A and B are mutually exclusive events, then what? Sorry, there's some. Sorry. Okay, so now we come back here. So if A and B are mutually exclusive, then we actually have this formula here. Now, probability of A or B. Now, this A or B meaning that one of the events happen or both can happen, right? So actually the notation is the union sign, all right? So what is this probability there? So this probability, as I say, is written as this. This means A or B, all right? And if A and B are mutually exclusive, then this is just the sum of the probabilities. All right, so it's like that. Is it okay? All right, so this is a formula for mutually exclusive events. Now we also have a more general formula. So this formula is, suppose your A and B are any 2 events, not necessarily mutually exclusive. Okay, then you also want to talk about this probability of A or B, right? So we know that it is like that. And what will this formula be? Will it be the same as this? No, it will be different. All right, because this one is only for A and B mutually exclusive. But in general, this is what you have. So you got probability of A plus probability of B. So this one same, right? But you need to minus of probability of A and B. Okay, so this is what we have here. All right, so that's all about mutually exclusive events. So now let's go to another concept. So here is another concept here. So it is the concept of independent events. All right. Now these independent events here. Now independent actually is a very simple word. It's just an English word, right? And well, everyone understands the meaning of independent. So the meaning is just like the English word independent. All right, so you see that the two events A and B are independent of one another if what? If the occurrence of one will not affect the occurrence of another. All right, so just like that, very easy to understand. So you say, oh, okay, I understand already, right? But in real life, sometimes it's not easy to check whether the two events are independent or not. All right, sometimes it's not easy to check. So therefore, we need some kind of formula to help us. So this is our point B here. Okay, so this is what we have. So we said that A and B are independent if and only if. Now, this if and only if is a notation. This one I explain later. So if and only if what? If and only if we have this formula. Okay, if and only if this formula holds. So this formula, what is it about? So it's probability of A, and then you see this intersection sign, right? So that means N. So probability of A and B is the product. So it's like that. So if this formula holds, that means A and B are independent. Okay, not. So let me now come back to this phrase here, if and only if. Now this notation, right? Now from the notation, you can understand this phrase. Can you see that this notation here, this is like a double-sided arrow. Yeah, double-sided arrow. So meaning what? Meaning that A and B are independent. Then the arrow can go this way, implies this formula holds. Okay, now our arrow go back. Now, if this formula holds, implies, so you see, arrow go back, A and B are independent. Okay, so that's the meaning of if and only if. So the arrow can go both ways. Now, a simpler word for this if and only if there actually is what? What's that word? Anyone can give me what is this word there? If and only if. Is there just one word to replace this? Anyone? Anyone or not? If and only if. If we don't say if and only if, what can we say? Anyone? Please don't put in the chat. As I told you, I don't see the chat because my screen is so full already. Can you just unmute and tell me?
Given that, Prof, is it?
Not exactly, because you see, the arrow is both ways. A and B are independent means this. Okay, independent means you got this formula. So another word for this is equivalent. Right. So you all see this word not equivalent. So A and B are independent is equivalent to you have this formula. All right. Okay, not equivalent. So if equivalent, if the word is too deep, that means same. So A and B are independent. It's the same as you have this formula. Everybody okay? Okay. So this actually gives a very very convenient tool for us to check independence. Okay, so that means you want to check independence, right? You just go and check whether this formula holds or not. If holds, well, that means independent. If doesn't hold, doesn't hold means not independent. Okay, now, okay, yeah. So let's go to our first question. Our first question here. So everybody look at this question. So we have a chip is drawn from a box containing 4 chips. So inside the box got 4 chips. And these are the 4 chips. Okay, so the chip on top of the chip got some numbers. So these are the 4 chips. And then A, B, C are the following events. So what is event A? Now, event A is, remember you draw a chip from the box, right? So event A is the first digit on the drawn chip is 1. Okay, then B is the second digit on the drawn chip is 1. And C is the third digit on the drawn chip is 1. Is okay? So first of all, you want to write down the 3 sets that represent the 3 events. All right, events can be represented as sets. Okay, so let's go and do this part first. Go and write down these 3 sets that represent the 3 events. Okay, let's go to our solution here. See, our solution is here. See, now you can see, right? Wow, our whole screen is full. Okay, so question is here, solution is here. So you want to write down the events as a set, right? So this is our A, event A, first digit on the drawn chip is 1. So how do we write down this set here? Anyone can tell me what are the elements inside A? Anyone? Just unmute and tell me. First,
1, 0, 1.
Okay, who want to say first?
1, 0, 1.
And then?
1, 1, 0.
Got any more?
0, 1, 1.
0, 1, 1, but the first digit not 1. Is it okay? First digit is 1. This one not 1. Okay, so actually we only have a 101 and 110. Is that all right? Okay, so only 2. I hope everybody clear. Okay, yeah. So this one okay, yeah. So then the second one will be quite clear lah. Second digit on the drawn chip is 1. Then you just go and look for those second digit is 1, and then you'll find that these 2. Okay, and then C is the third digit is 1. So third digit is 1. Which one? 0, 1, 1, right? And then the 101. Okay, so this is how we get it. All right, any questions here? Any questions? If got questions, can unmute and ask me. Okay, don't have, is it? Okay, so that means this one, yes.
What are the difference between even and set?
Can you say again?
What are the difference between event and set? Yeah.
Even what?
Event and a set. What are the difference between these
event and a set, is it?
Yeah, exactly.
Event actually is something that happens. You know, event is actually an English word, right? So when you say, there's an event, that means something happens, right? So this event is actually a subset of the sample space. Sample space is, all the possible outcomes. Yeah, so event is actually a subset of a sample space. It's a subset, right? So this event can actually represented by a set, like what we do here. Is it okay?
So basically, event is also a set, right?
Event can be represented by a set. Represented. You can represent it by a set like this. Is it okay? Okay, yeah.
Thank you, Professor.
All right. So now let's go to let's go and do part A. Yeah. Now this part A here is like that. So you want to show, show that events A and B are independent. Okay, you want to show that 2 events are independent. Okay, how to show? I remember this what we did, right? So we say, how do you show if 2 events are independent? Well, you just go and show this formula holds. Because independent means this, right? So you want to show independent means you go and show that this formula holds. Okay. Now what do I mean? go and show that this formula holds. Well, that's very easy. Show that the formula holds, meaning that you go and show that the left-hand side equal to the right-hand side. Got it? You just go and show that left-hand side equal to right-hand side. Okay, so this is our plan. So we want to show that this formula holds, right? And to show this independent, you shall show that this one equal to this one. Okay, so I say we want to show that left-hand side equal to right-hand side, right? Okay, let's go and do. Now, how do you show that left-hand side equal to right-hand side, right? So meaning that you have to find out all the probabilities. All right. So meaning that you must find out probability of A, you must find out probability of B, and there's a third probability, that is probability of A and B. Yeah, everybody can see my type letters here, right? Okay, so we want to find these three probabilities. So we find together, okay? So let's go and get probability of A first. Okay, how to get probability of A? And just now you already know that your A is represented by this set here, right? And your 101, your 110. So from here, can you tell what is the probability of event A happening?
Half.
How do you get half?
It's 2/4.
Yes, it's 2/4. All right. So actually, what he's saying is that the 2, why 2/4 there? Because event A has 2 elements. Why over 4? Because overall there are four elements here. So it's 2 out of 4. All right. So that's how we get this. All right. So I hope this is clear, So that means event B, probability of B, they also the same thing, right? So you see, this one also 2 elements. So also 2 out of 4. Yeah, so also 2 out of 4. In fact, or you can also say that probability of C is also like this, right? Yeah, although we don't need it here. So probability of C here actually is also 2/4. It's okay? So now I want to find probability of A and B. Probability of A and B. All right, so A and B, you realize that I call it A and B, right? I don't call it A intersect B, right? Although this A and B is actually represented by the set A intersect B. But I will just say probability of A and B. Now, how do we find this? How do we find this? Anyone? How to find this?
Same number in the set.
What?
Yeah, find the same number in the set. What is it?
Oh, go and find intersect, okay. So we follow what you say, So he said go and do A intersect B. All right, so you got set A here, you got set B here, right? So let's do intersect. Okay, intersection, what do you get? Your A and B intersect. What do you get?
1/4.
You only get 110, right? So you actually get this one. Okay, so you get this one, probability of this trip 110. Now here 110 is only one trip there, so it's actually 1 out of 4. Is this okay? Everybody okay? Okay, right? I think okay at this moment. Now let me throw you a question. Question. So just now we already found probability of A and B. We found that it's 1/4, right? So can I do it this way? Can I do it this way? Probability of A and B. Can I say this is equal to probability of A, probability of B, and then equal to, and we have here probability of A is 2/4, right? So 2/4 times 2/4. And then I also get 1/4, right? Can I do it like that? Can we find probability of A and B by this?
Yep.
Okay, one person say can.
Cannot, unless the question tell you that it is independent, then you can use it this way.
Yeah. This one is correct. Okay, so actually the answer is cannot. Right? This one cannot. This one. Why cannot? Because you cannot use this formula. You see here, you are using the formula, right? Probability of A and B equal to probability of A, probability of B. You use this formula, you can only do that provided that A and B are independent. But you don't know A and B independent or not, because your job is supposed to show, to show that it's independent. But before you show, you cannot use this. All right, so that's why I say here, you cannot do this. Is that all right? So in fact here, the only way to do this is this one, the third line here. All right, not? Okay, so we clarify this point already, yeah? Okay, so now I think we can conclude that. So we have found all the three probabilities. All right, so your left-hand side of the formula is what? Probability of A, probability of B. And of course, you go and multiply together. 2/4, and then you get 1/4. Okay, so this is the left-hand side. No. I think my left and right mix up. So this is actually the right-hand side. So your left-hand side of the formula actually is probability of A and B. And we have found that this is 1/4. Okay, there's the third line here. Okay, it's 1/4. All right, so therefore what? Therefore, left-hand side equal to right-hand side, right? Left-hand side equal to right-hand side. So that means you have this formula. So the formula holds, right? Yeah, formula holds. And therefore what? Therefore A and B are independent. Is it okay? All right, so this concludes part A. Any problem? So this concludes part A. Any questions? Any questions asked now? Okay, so maybe no questions, Okay, so part A done. Part B, part C also similar. So part B, part C, I will not go through, but I would like to go through part B. All right. Now part D is like that. You want to show that events A, B, C are dependent. You see, just now is you want to show independent. Now you want to show dependent. So how to show dependent? How to show dependent? So actually, it's also the same. All right, you see, independent means this formula holds. Meaning what? If this formula does not hold, formula doesn't hold means what? Not independent. Okay, formula doesn't hold means not independent. Not independent means dependent. All right, so that means dependent means this one is the formula is here should be not equal. Is that all right? Okay, y'all. So now let's go to part D here. So to show that A, B, C are dependent, this is what we are going to do. We are going to show that probability of A and B and C not equal to the product. All right, so this one actually is generalized from here. Here only 2, right? But when you have 3, also the same thing. It's a product. All right, so here dependent, right? So that means you will show that this one is not equal. Is that okay? So this one is not equal here. Yeah. So let's go and do this. Yep. So let's also go and find the left-hand side, find the right-hand side. So I think we do the right-hand side first because we actually already know the probability of A, probability of B, probability of C, right? So just now we found already. So it's like that. Okay, let's find the left-hand side. Probability of A and B and C. Okay, A and B and C. Now this one here, let me go to the question. Your A is first digit is 1, right? B is second digit 1, C is third digit is 1. So when you have A and B and C, meaning that your first and second and third digits are 1. Okay, make sense? So that's the meaning of N, right? First and second and third digits are 1. So we must go and look for the chip 111. Okay, so you think inside the box got this chip or not? Inside the box, do we have this chip 111? Anyone? No. Don't have, right? So we don't have this chip there. So what is this probability? So there's no such chip. So the probability actually is a null event. So the probability is 0. So okay. All right. So you see, your this side, right hand side, left hand side is 0. Your right hand side is 1, 8. Right. So that means this is not equal. So since not equal, so we say that the events A and B, A, B, C are dependent. Okay. Any questions? So that completes part B. Is it okay? All right. So I think
Okay.
okay, yeah. Okay, so now let's before we go to the next equation, next question, let's do some more summary. Oh, this is also my style. Huh? So usually I do some summary, then go to question, then some more summary. Okay, so now let's do some more summary. This time we are going to talk about conditional probability of A given B. A and B are events, right? Conditional probability of A given B. Now, first of all, we talk about the notation. Now, this is a notation, probability of A given B. You see the straight line here, right? A and then straight line, then B, right? So the straight line, you can pronounce it as given. Probability of A given B. So it's like that, right? So let us explain the meaning first. What is this meaning? Conditional probability of A given B. Well, the meaning is like that. So they tell you that B has happened. So that's the meaning given B, right? They tell you that B has happened. And then they ask you, what is the probability of A happening? Okay, so they tell you already B has happened. Then they ask you, what is the probability that A is happening? Got it? So this is called conditional probability of A given B. All right, so probability of A happening, condition on B has happened. Okay or not? Okay, so now let's look at the formula. The formula is actually like that. So we have probability of A and B divided by probability of B. So divide by the probability of the event that is given. Okay, so it's like that. Okay. So now with this, I think we can go to the next question. Okay, let's go to this question here. Consider the population of all families with 3 children. Okay, population of all families with 3 children. So let G denote a girl, B denote a boy. So assume that a child is equally likely to be a female or male. And then we'll use this kind of notation. All right, so if you see BGB, meaning that the first child is a boy, second one is a girl, and the third one is a boy. Okay, so first of all, we shall write down all the possible children compositions for a family with 3 children. Okay, right. Okay, so this is what we're going to do, part A. So we are only considering families with 3 children. All right, so what are the possible compositions, children compositions? Compositions meaning something like this, BGB. That's one possibility, right? Maybe another one can be GBB. That's another one, or maybe a BBG. That's another one. Okay, so that's the meaning, right? So I think you understand children compositions. So can you tell me what's the total number of possible compositions for a family with 3 children? What is the total number of possible compositions?
8.
9,
8. Okay, 8. And how do you all get 8 leh? How do you all get 8 leh?
Is it 2 to the
Power
power of
3.
Yeah, you all see 2 to the power of 3, right? So what they are saying is 2 times 2 times 2. So that's why it's 8, right? You all know why 2 times 2 times 2 or not? Well, actually it's like that. So 3 children, right? So the first child, 2 possibilities. So that's why I have 2 here, 2 choices. Then second child, also 2 possibilities, boy or girl, so also 2 choices. And third child, also 2 choices. So that's why 2 times 2 times 2. So we know that the total number of compositions is 8. All right, so then we are going to write down systematically. All right, systematically, well, everybody has your own system. Everybody has your own system. So you just follow your system, write down in a systematically manner. Okay, so this is my system. So my system is like that. So you see, I consider these 4 cases. No boy, 1 boy, 2 boys, 3 boys. And then in each of this, well, it's more manageable, right? For example, no boy means what? Means only girls. 1 boy, 1 boy, then the boy can be the first one, can be the second one, can be the third one, right? So this is how I do it. Okay, so that's how I write down the 8 possible compositions in a systematic way. Okay. All right, so let's go and do part B. A family is selected at random from the population. Okay. What is the probability of obtaining a family with exactly 2 girls, given that the family has at least 1 girl? Okay. Now look at the structure of the question. Yeah, look at the structure of the question. What is the probability of something obtaining a family, something here? Given that another thing, right? The family is like that. Okay, and you see the structure? What is the probability of this one given that this one? Can everybody see the structure? Okay, what is the probability of obtaining this given this? All right, so this is a conditional probability. Probability of this one given this one has happened. All right, so conditional probability. All right, can everybody see that? All right, it's important that we are able to see that this is a conditional probability. All right, so now we go and do that. How to do that? Well, let's go and define the 2 events. You can see that there's a 1 event here. What is the probability of A given B? Can you see that? So let's go and call them A and B. So I shall let my A and B be like this. So you notice that my A is what? The first item, family with exactly 2 girls. Right? Given that, so this will be my B. Family with at least 1 girl. All right, not? Okay, So the probability that you want to find is probability of A and B. Probability of A given B. Yeah, so this is what we want to find. Probability of A given B. All right, and of course, this one is the formula. Any questions? Everyone can understand or not why we are finding this probability? Okay, any questions? Okay, looks like okay, Okay, looks like okay, then we really go and find this probability. Now, to find this probability, you can see that there's a numerator, there's a denominator, right? So meaning that you must go and get numerator, must go and get denominator. So let's do here. Let's go and do here. We do the easy one first. We do this one first because this one looks simpler, right? So let's go and get probability of B. What is B? Family with at least 1 girl. So what is the probability of B? What is the probability that you choose a family and that family has at least 1 girl?
7, 8.
Because you see, you got all your compositions here. See, all your compositions are here. At least 1 girl. At least 1 girl. Well, looks like all got girl, right? Except the 3 boys. Right? So you can see that there are actually 7 cases. Everybody clear? Okay, I think this one quite clear, Okay, then we go and do the numerator. Numerator is A and B. Right? So what is the meaning? Probability of A and B. I mean how to find this probability, A and B. A and B are two events N, meaning that the two events must happen at the same time, right? Must happen at the same time. Happen at the same time, and then we see this probability of A and B, right? And then then we recall before this, we talk about this. You all see this or not? You all see this formula here? Probability of A and B. Probability of A times probability of B. Do you think we can use this formula?
Cannot.
Can or not?
Cannot.
Cannot. Why cannot?
That one is for independent.
Because this formula, you can use this provided you know that A and B are independent. All right, so only independent you can use this. But here, do we know A and B are independent or not? You look at it, this one difficult, very difficult to tell. How do you know these two independent or not? I think very hard to tell, So that means you cannot tell, right? You don't know for sure. So that means don't use. Okay, don't use. Then if don't use, then how to find it? Don't use, how to find? Well, then you go and find directly. Okay, how to find directly? That means you must really look at the meaning of a family with exactly 2 girls and a family with at least 1 girl. Okay, so you take intersection, it becomes what? It becomes what? This one is exactly 2. This one is at least 1. Intersection meaning become what?
2.
All the 2 girls.
Intersection become 2,
2 girls.
2 girls only.
Intersection become 2 or become 1? Or become at least 1?
2 girls only.
2 girls. So they are saying that the intersection becomes exactly 2 girls. Exactly 2 girls is A. All right. Now I know some of you must be wondering, why intersection is just 2 So we go and draw a diagram, okay? Now let's go and draw this set A, exactly 2. 2 is only 1 point, so that means this point is 2. And then let's go and draw B. Now B is family with at least 1 girl. Now 1 is here. This one just now 2 is that means only 1 point. Only 1 point here. Then this one now family with at least 1 girl, right? At least 1. Now, you all know from secondary school, this is how we draw it, right? At least 1. It's like that. Okay. Yep. So it's like this. At least 1 is like that. Right? So it's from here and all that. Okay. So now I think you can see very clearly. Now, this one is a range. You intersect with this point. You intersect with this point. So what is the outcome? The outcome is only this point 2. So that's why the intersection is just A, family with exactly 2 girls. Yeah, so it's like that. Is it okay? Are you all right here?
Okay.
Okay, yeah. All right, so this is how you get this thing here. And then, of course, now you just look at the probability of A. Exactly 2 girls. Exactly 2 girls, meaning that 1 boy. All right, so then you just look at the 1 boy case. There are 3. Okay, 3 cases. So that means 3 out of 8, no? Is it okay? Yeah. All right, so you have found numerator and denominator, and then you just put in here, and you will get the answer. All right, so that is part B lah. Okay, any questions?
Professor.
Okay. Seems all right, y'all. Seems all right, then yes.
What's the meaning of the A and vertical line and then B? Like instead of probability.
It's not 1. This is called given. The straight line is called given. Probability of A given B. So this one here, the first item is like A. And then you see this word given, right? Given this thing. So this is my B. So this is probability of A given B. That's the conditional probability.
All right, thank you.
Okay, so let's go and look at C. C is also similar. Now, everybody go and look at question C on your left side. What is the probability of, you see, probability of this one, and And then you see this word again, given that, given what now? Given that the eldest child of the family is a boy. Okay, yeah, can you see the structure? What is the probability of this thing given that this thing? Everyone can see or not? Can, right? So should we call this A and B again? Maybe change, huh? Let's call the first thing, let's call it C. And then given that this thing, let's call it D. Okay, so let's go and do this. Yeah, so now we are at part C. So we let C be the first item, a family with only one girl. Okay, and then D is the eldest child of the family. Is a boy. Yeah. So eldest child is a boy. That means a family with eldest child, a boy. All right. So this is my C, this is my D. Okay. Right. So now let's go and see what we want to find. All right. So we are looking at probability of C given D. All right. Probability of C given D. And this is the formula. Okay. All right. So now we know what to find already. Let's go and find. So we shall find the numerator and the denominator. Okay, so let's go and do that. First of all, let's get the probability of D. The letter is so small. You see, is it here? Okay, let's go and get probability of D. So what is probability of D then? What's probability of D? D is actually a family with eldest child, a boy, right? Family with eldest child, a boy. So should we go back to just now the compositions? A family with eldest child, a boy. So how many cases are there?
4, 8, 4, 8.
4,
4 out of 8.
4 out of 8. Eldest child, a boy. So you just see the first one is boy 1. Okay, you go and count. I think you get 4 cases. All right. So you say 4 out of 8. Is it? 4 out of 8. Actually 4 out of 8 is half. So I straight away put half. Is it okay? All right, all. Okay, class. Do you think if we don't count, just now the 4 out of 8, can we also say that family with eldest child, a boy, the probability is half? Can we say it's half without counting?
Can.
Why can they?
Because your first branch is boy or girl.
Because the first child is either boy or girl and it's an equal probability. Is it all right? All right, so actually you no need to count, you also know it's half. Okay, so now the next thing is we'll go and look at C and D. All right, so we are going to take intersection. Only one girl and eldest child, a boy. Okay, only one girl and the eldest child is a boy. All right, so in knowing these two, let's go to our compositions here. Eldest child, a boy. All right, and only one girl. Only one girl means 2 boys. Only one girl means 2 boys. All right, so you just look at the 2 boys case, and the eldest one must be a boy. So how many cases do we have? 1, 2. Right, only 2 cases here. So only one girl and eldest child is a boy. So only 2 cases. All right, so 2 cases only. So therefore, this one is 2 out of 8. Yeah. So this is a 2 out of 8. So 2 out of 8. Okay, now. Okay, class, is it okay? Yeah. So you see, you got the 2 probabilities already. Then you just go and put in, and then you'll get the answer. All right. Okay, any questions?
No.
Okay. Then we go and do some more summary. So we done this, we done this. Those that I skip, I'm going to do next week. All right, yeah. So that's for the questions next week. So now let's go and talk about random variable. Yeah, random variable. Random variable X. So usually random variable will use a capital letter X to denote it. I hope you have watched some lectures already. So these random variables, there are actually two kinds. One kind is X is a discrete random variable. Then another kind is X is a continuous random variable. Right? So what's the difference? Well, discrete means that the number of values that X can take is countable. Okay, the number of values that X can take is countable. For example, X can only take 1, 2, 3, 4. So you see it's countable, right? And what about this X is a continuous random variable? Well, here the number of values that X can take is non-countable. So one is countable, one is non-countable. So then you'll be wondering, right? So what is a non-countable? So an example could be is a continuous interval. For example, the interval 0, 1. X take values inside. All right. So do we know how many values inside the real interval? Well, of course, it's cannot count, right? So in this case, X is continuous. Is it okay? Yeah. So I mean, it's just an example. All right. So now we roughly know what is a discrete and what is a continuous random variable already, right? So let's look at some of the properties here. Now, when X is a discrete random variable, we talk about this thing called probability mass function, PK. All right, now PK is a notation. Probability mass function, PK. So actually, what is the meaning of PK? It's a probability of X equal to K. All right, so actually it's a probability that X take the value K. Okay, so of course your K can change, right? Your K, the values can change. So all these numbers, they constitute this thing that's called probability mass function. Okay, and this probability mass function PK, when you sum up all the K values, you will get 1. All right, so this is a famous property of this probability mass function. So now let's come to continuous random variable. Now, continuous random variable, do we have probability mass function? No, we don't have. All right, but we have this thing called probability density function. All right, so you notice that they have a different kind of functions, right? So when you see probability mass function, straight away you know your X is discrete. When you see a probability density function, then straight away you know that your random variable X here is a continuous random variable. Is it okay? Okay, now this probability density function, usually we denote it by a small fx. Yeah, it's a small fx. Then you want to ask me, right? Just now this probability mass function pk, what we say is a probability of x equal to k. So this probability density function, is it also a probability? The answer is no. This one is not a probability. All right, but we use it to calculate probability. Itself is not a probability. All right, so now we look at the famous property of a probability density function. If you integrate it over the whole real line, okay, from -infinity to infinity, that means the total area under the curve, it is 1. All right, always 1. Just like here, the summation here is always 1. Okay, so this is a famous property. And the next thing is, we want to see how we can use this fx here to calculate probabilities, right? So it's actually on the next page. Now, probability of x between a and b. Probability here, your x is continuous. Probability that your x, the random variable x, is greater than a and less than b. Okay. Now here we realize that it's actually the same as this. Here we have an equal sign here. Okay, so you see, this one is strict inequality, right? But here got equal sign, right? And we find that here, whether you put equal sign or not, doesn't matter. The probabilities are the same. All right, this only happens in a continuous random variable. All right, so whether you put equal sign or not, doesn't matter. And how to find this probability then? Now, you see, you take the probability density function and you integrate from A to B. Integrate from lower limit to upper limit. You see, integrate from lower limit to upper limit. So this is how you find the probability. Now, this thing here, when you take a function and you integrate from A to B, right? Graphically, it means this. Everybody can see this graph here, right? Now, this is your x-axis. Then say you draw your fx here. This is your function fx. Then suppose this is a point A here. This is a point B here. Now, when you integrate fx from A to B, this is the meaning. So from point A, integrate until point B, right? So this actually means the area under the curve from A to B. And this is the area, right? You see, this is the area. This is the integration. Okay, see, this is the area. This area is this integral. Yeah, this integral is this area. All right. So what it then means is that your probability is what? Your probability is an area. Yeah, so that means your probability is actually an area. Yeah, your probability is actually represented by this area. It's an area under the probability density function. Yeah, everybody okay or not? Right, so that's the point I want to make tonight. As for this one, this one is FB, capital FB minus capital FA. The capital F is actually another function. It's called distribution function. That one we'll do next week. Okay, so this one is also FB minus FA. The capital F is another kind of function. All right? Okay, no? Okay, so at the moment it's until this. So now let's go and see our question. Let's go and see this question. So let X be the lifetime of a battery in hours. Okay, let me put here and let me go and get this highlighter. So this is our X. So this is the random variable, right? So what is it? It is the lifetime of a battery in hours. Now this random variable X has the following probability density function. Okay, so they tell you that this X has this probability density function. So meaning what? Meaning this X is what kind of variable? Continuous or discrete? It has a probability density function. Yeah. So it's actually a continuous random variable because only continuous random variable has a probability density function. Yeah, okay. All right, so we know this one is continuous random variable. So this is your probability density function. So you see it's like that all. You've got some expression here for X more than 0 and 0 otherwise. All right. Now find the probability that the lifetime of a particular battery, meaning your capital X, is less than 200 or greater than 400 hours. So we are looking at part A first. So find the probability that X, lifetime of particular battery X, is less than 200 or greater than 400 hours. Okay, so let's go and do this. All right, so this is our X, lifetime of battery in hours. This is a probability density function. Yeah, the short form is called PDF, right? Probability density function. Okay, so let's go and do part A. So first of all, we want to interpret what is this probability. Probability that X is less than 200 or X is greater than 400. Okay, so let's go and write this down. So basically it's like that, right? Probability that X less than 200 or X more than 400. Is it okay? I think okay lah, huh? And then now this word here is or. Now we know that or in our probability. Oh, I see. Before we do this, the or actually we understand it as the union sign. Okay, understand it as the union sign. So it's this one, union, this one. Although we don't say union, we will pronounce it as or. But notation, we will put it as this one or this one. Use the union sign. All right, if you don't put this word or, that's the sign that you'll be using. Okay, so it's this one or this one. Okay, and then you see that here I put this one plus this one, right? You wonder why I go and put plus, right? You must be wondering why how I know that I must go and put a plus here. Why don't I use a multiplication or whatever? Do you all know why here we have this plus sign or not?
Or.
Or, you mean all means plus sign, eh? Now, I think at the beginning, huh? What? Yeah, someone say something?
Independent.
Independent. Independent, not this union. Independent is an intersection. I know in the beginning it's a bit confusing. Independent one is what? Not union, it's intersection. A and B. Okay. But earlier on, we did encounter this union. And it is over here. You see here? If A and B are mutually exclusive, then we have this. Probability of A or B, which is like that, is the sum. Okay, and if A and B are any two events, that means may not be mutually exclusive. Then the general formula is like this. All right. Okay, so this is about the union thing. So you see we have two formula here. So then you see I put here just plus. So it looks like I'm using only the first one. I'm using the first one. I'm not using the second one, right? I'm using the first one. If I'm using the first one, meaning that I know that A and B are mutually exclusive. Are A and B really mutually exclusive? Class, what do you think?
Yeah, I think so.
Mutually exclusive. So we go and check mutually exclusive. Mutually exclusive means what now? A and B have no outcomes in common. So you go and ask yourself, this one x less than 200. This one x more than 400. Yeah, you go through your brain slowly. Got anything in common or not? Nothing in common, right? Yeah, one is less than 200, another one is more than 400. So no outcomes in common, right? Yeah, so confirm these two are mutually exclusive. Okay, so mutually.
Are there events, right, that out of these four, right, maybe they have three that doesn't hold and one that holds. Is there such a thing?
You mean you're talking about three events?
Like they're mutually exclusive. Then instead of like all not holding, right, like maybe three of them holds and then like one of them doesn't hold, or is it always is like all of them doesn't hold one, if you are talking about mutually exclusive?
Mutually exclusive, basically we are looking at they have no outcomes in common. So if you have three events, three of them they cannot have outcomes in common one.
So if one of it hold, the other three just automatically hold already.
But you're considering the three of them, right? So they shouldn't have outcomes in common. So when you come to A and B, you see the intersection is empty, right? So you intersect any two of them should be empty. You intersect any two of them will be empty.
Okay.
Yeah. All right. So now we come back to this question. So here it's very clear that these two have no outcomes in common. So that's why these two here, they are mutually exclusive. And that is why here you can use this formula. Probability of A or B is the sum, just the sum. So that's what I'm doing here. Is it okay? All right, yeah. Okay, so this is what we have here. And then we just go and calculate each of this probability. This one is a continuous random variable. How to find the probability? Use the probability density function and integrate. Okay, now the first one, x less than 200. Well, let me go back to this thing here. Now, just now we have the, see we got this thing, right? So we say we must integrate from lower limit to upper limit, right? Now, this one is less than 200. Surely the 200 is the upper limit. Where is the lower limit there? How I know it's 0? How do you know it's integrate from 0? Upper limit, I think you all know, because here they say less than 200, right? So integrate until 200. But how do you know this one is 0?
Cause is time, there's no negative time.
Well, it's because here, if you look at the expression of fx, you only have some expression for x more than 0. So the small x here has to be more than 0. Okay, so that's why you integrate from 0. Okay, now the second one, probability of x more than 400. Well, more than 400, definitely 400 is the lower limit, right? So see 400 here. Then upper limit, well, upper limit they didn't say. So if they didn't say, then you see here, there's also no upper limit, right? So that means you integrate until infinity. So from 400 until infinity. Is it okay? All right, then you just put in your expression here, then really go and integrate. You see, go and integrate all. Then I leave you to integrate and go and put in the limits, and you will get this. Okay. All right. So all these details I won't go through. Okay. Yeah. You need to do it yourself. Okay. So that's part A lah. Any questions?
If you right, if examination in exam right, if you are going to sub in like infinity, right, do you get penalized if you didn't write it like properly, as in like instead of writing infinity, right? By right you're supposed to put like limit, let's say t approaches infinity, then integration is 400 to t.
No. You just put 400 to infinity. We do integrate to infinity.
Don't have to write
This
it.
is a proper representation.
Like after you integrate already, then you got the square brackets.
Yeah, correct.
You can.
So
okay.
yes, this is a proper way of writing.
Okay.
It's a proper way of writing. Yeah. So I think this one okay, Then we go to part B. Okay, find the probability that X, the lifetime of particular battery, lasts more than 300 hours. Given that, wow, now we are very sensitive to this kind of thing, given that it has already been in use for more than 200 hours. Given, that means tell you something already. Looks like a conditional probability to me, man. Right? What is the probability that X more than 300, given that it has already been in use for more than 200 hours? So let's go and write this down. This is a probability of X lasts more than 300 hours, right? That means more than 300. Given that what now? The battery has already been in use for more than 200 hours. So how to write this? If battery has already been in use for more than 200 hours, what can you say about the lifetime of this battery?
At least
More
500.
than 200.
Yeah, more than 200.
Oh.
Just like that, just interpret like that. Okay. So actually it's like this. So this is the conditional probability that you will be finding. Okay, now we go and find. See, this is the one probability of X more than 300 given X more than 200. So we'll do the conditional probability formula, which is like that. Probability of A and B divide by probability of B. Okay, so it's like that. Okay, what is the numerator, class? How do you do this intersection?
More than 300.
More than 300 intersect more than 200 becomes what?
More than
More than
300.
what 100?
200.
200, 300.
More than 300.
I think you're all a bit confused. So when you confuse, we draw a diagram. Okay, so we have 200, we have 300. So let me put a 200 here. So 200 is here. And then we have a 300 here. Okay. Now let me go and draw x more than 300. So x more than 300, how to draw? Now from secondary school is like that. So you got an open circle, then you draw like that, right? So that means more than 300. Then more than 200, more than 200 means this. So you got a circle here, then you draw your arrow like that. Okay, so that means x more than 200. So now I think it's very clear. You take the intersection. And where is the intersection?
More than 300.
More than 300. Okay, yeah, so when you are not sure, you just draw a diagram. So x more than 300. Okay, now we just go and do integration. So the numerator is integrate from 300 to infinity. Then denominator is 200 to infinity. All right, just go and integrate the probability density function. Go and put this expression inside. Go and integrate and go and put in the limits. Well, that's what you have. You can go and work out the details. Is it okay? Class, all right or not? All right, Okay, all right already. Let me go to, okay, so this is the one, right? Let me go to, yeah, now let me look at this question here. Okay, let me look at this question. It's related to our summary tonight. All right, not exactly, but I would like to analyze this question with you tonight. Okay, yeah. So, well, when you got a question, let's go and read the question, right? So, everybody look at your right side, Everybody look at the right side, A factory has this automatic machine that produces an important part. Okay. Now, past records indicate that at the beginning of the day, the machine is set up correctly 70% of time. All right. Past experience also shows that if the machine is set up correctly, it will produce good parts 90% of the time. And if it is set up incorrectly, it will still produce good parts 40% of the time. And then if the machine is set up and produces a good part, what is the probability that it is set up correctly? Right? Okay, so I think you all know how to read. And then after reading through then your mind got many things, right? You don't know how to start, right? You may not know how to start. Okay, so given such a situation, what do? You read once already, you kind of know what they are talking about, but you don't know how to start, right? So what you do here is you go and read second time, all right? Or maybe you go and read the third time. And when you read second time, when you read third time, that time, you need to pay attention to what are the phrases that they repeat. What are the phrases that are repeated? All right, because those are the main things. That's why they repeat a few times, right? And you go and pick up those words. So with this in mind, we read again. Okay, this factory got an automatic machine that produces an important part. Now, past records indicate that at the beginning of the day, the machine is set up correctly 70% of the time. So you see, I mark this set up correctly, right? Because it happens later on also. Now, past experience also shows that if the machine is set up correctly, you see, same thing. It will produce good parts 90% of the time. How I know I got to highlight good parts? Because later on, you also get this. And then we carry on. It is set up incorrectly. set up incorrectly. Well, I also highlight. Why I highlight that? Well, because it's also related to set up correctly, right? You see, set up correctly. So here set up incorrectly. Well, also related lah. So it will still produce good parts. Then you see, good parts. 40% of the time. If the machine is set up and produces a good part, you see here, good part, good part again. What is the probability that it is set up correctly? Right, so you see, set up correctly again. Right, now do you all see? So you can see that the phrases are repeating. And after reading a few times, you are able to catch that and you highlight it. Okay, all right now. Okay, so now you highlight already, right? Then what is the next thing to do? Okay, the next thing to do, because this sounds complicated, so the next thing to do there is to go and define all these phrases. Then like machine set up correctly, machine set up incorrectly, good parts, right? Machine produces a good part. So all these, let's go and define them as events. Okay, so let me go to that. See here, machine set up correctly. And see here, I call it MC. Machine set up incorrectly, I call it MIC. All right, and then here, machine produces a good part, I call it GP. So you see, I define the events. All right, okay, now the events are defined. Then what's the next thing? Okay, the next thing, now inside our question got some numbers. So I guess those numbers got some importance. Then you see here, 70%. Any more number? And 90%. 40%. All right, so you see all these numbers, right? Okay, now we go and write down these numbers because these numbers got meaning one. Okay, so when you write down the numbers, it will be in terms of these events, MCR, MICR, GP. Is it okay? All right. So we'll go and write this down together. Let's go and write this down together. Maybe I write it here. Okay, so I will write below the question. So everybody look at the question. Yeah, I'm going to write down these numbers. Here, to be careful, okay, we go and look through every sentence. You don't jump here and there, okay, in case you miss one. Okay, the first sentence actually no number. Now, second sentence, okay, second sentence got a number. Past records indicate that at the beginning of the day, the machine is set up correctly 70% of the time. Okay, 70% of the time. It is a probability. Probability of what? Probability that machine is set up correctly. Okay, over here, you already define it. It's MC. So probability that machine set up correctly is 70% of the time. So probability of MC is 0.7. Is it okay? All right, so that's the sentence. Now you go to the sentence, the next sentence. Past experience also shows that if the machine is set up correctly, it will produce good parts 90% of the time. Okay, it will produce good parts 90% of the time. Okay, good parts, a good part is produced, that is GP. It will produce good parts 90% of the time. Is it like that?
Need intersect.
Need the condition.
Need a condition. In this 90% of the time is provided what? Provided that
given condition.
Machine set up correctly. Machine set up correctly, then given this. Can you see this word here? Can you see this word if? Well, it's another way of telling you it's a condition on this. If the machine is set up correctly, provided that the machine is set up correctly, it will produce good parts 90% of the time. So it's not so simple. Yeah, it's not so simple. So actually it's good parts. Yes, it's good parts. Probability of getting a good parts given machine set up correctly, given MC, all right, given that machine is set up correctly. Is it okay? So this is actually the probability. Probability of getting a good part given machine set up correctly is 90%. Right? Okay, y'all. Now you go to the next sentence. Yeah, you go to the next sentence. Next sentence, where is it? If it is set up incorrectly. Why? Can you see another if? If it is set up correctly. So now is a condition that the machine is set up incorrectly. It will still produce good parts 40% of time. So this one is good parts. Given what? Machine set up incorrectly. Okay, given MIC. Yep. And this is 0.4. Is it okay? Everybody okay until here? Okay, until this sentence? All right, so let's go and do the last sentence here. If the machine is set up and produces a good part. Wow, can you see another if here? So they tell you this. If the machine is set up and produces a good part, what is the probability that it is set up correctly? What is the probability that it is set up correctly? What is the probability that it is set up correctly? Probability that machine set up correctly? Is it just like that? What is the probability that it's set up correctly? Is it just like this?
Condition of good part, I guess.
Condition on it produces a good part. So if the machine is set up and produces a good part, so that's why you got the good part here, right? So given that you get a good part, so they are asking you this, right? So this one, what is this equal to then? Well, this is unknown. This is what you need to find out. So everybody okay here?
Sorry, sorry, because the N, right? Why is it not intercept? If the machine is set up and produces not intercept, produces good part.
You realize that we actually don't consider this setup. We actually don't consider this because this one is if the machine is not even set up, I cannot do anything. So cannot produce a good part at all. So this one is like this is like trivial. So this one is nothing. So the main thing here is if the machine produces a good part. Is that all right?
Okay.
And it's not intersection. It's condition on this. It's not set up correctly and produces a good part. It's not and. Rather, it is tell you that produces a good part, given produces a good part. What is the probability that is set up correctly? So it's different from intersection. So it's like that. Oh, okay, y'all. Okay, so this is what we have. So this is what we have. All right, so we are given this one. You see all these are recorded here, right? So this is what we have, and you want to find this. Is it okay? So by the way, because here probability of MC is 0.7, so we also know that probability of MIC is because this is the opposite of machine set up correctly, right? This one is machine set up incorrectly. So it's the opposite of this, the complementary event of this. So it's 1 minus 0.7, so it's 0.3. So this part is okay, right? Yeah. All right, so you want to find this. And how to find this there? How to find this is kind of complicated. So maybe I go to something else first. So we stop here for a moment. So that means we analyze the question, we know what to find, but don't know how to find yet. So at least we know what are the things given, and we also know what to find, but don't know how to find yet. So now let me go to something else. Now you all see the left side here, right? So this is actually our teaching plan. Now this file I also uploaded in our course site, our main course site. Okay, so you can also go and see this file over there. So these are our weekly activities. So tonight we are doing tutorial 1 and course briefing. Well, actually this thing is called course briefing. And then next week we will do tutorial 1, finish tutorial 1 and some part of tutorial 2, all like that. So over here, these are our lecture. So you can see that our lecture is quite fast. Yeah, it's quite fast. So that means every week you need to follow the weekly schedule and go and watch the videos. Okay, yeah. So it's like that. So I'm teaching the first 2 topics, probability and statistics, and also numerical methods. All right. So my lecture is supposed to finish at week 6. Then after that, Prof. Teo his lecture will begin. So that's the Fourier analysis, Laplace transform, and the partial differential equations. Okay, yeah. So over here, nothing special. So we'll have a tutorial, and then we'll have recess. So recess is a time for us to study. Yeah, study all the things that we learned before. And when we come back from recess, we will do a quiz on a Saturday. All right, everybody need to come back to school, go to the lab to do a quiz. So it will be in the afternoon, 1:30 onwards. Because our class is quite big, so there'll be 2 sessions, 1:30 to 2:30, and then 2:45 to 3:45. Okay, so the quiz admin, he will put you all into the sessions. Yeah. So this will be, you will know it when nearer to the time. Okay, so our quiz 1 is quite heavy. So it will be on all the things that I taught. All right, so probability and statistics and also numerical methods. So we will cover tutorial 1 to tutorial 6. So this is a big quiz. So it's almost like half an exam. All right, and then to reinforce these 2 topics, we also do our assignment 1 by this Sunday. Our assignment 1 is also on probability and statistics and also numerical methods. So that's why we blend together, quiz, assignment together. So that means we study the things and then we go and do assignment and go and do the quiz. All right, so hopefully this will reinforce our concepts. Yeah. Our assignment and our quiz, they are all OASIS assignment, OASIS quiz. So meaning computerized. All right, yeah. Assignment, so quiz is 1 hour, right? Assignment is actually also 1 hour, but you can choose when you want to do it. It's up to you. So we'll actually open it for 2 weeks. So during the 2 weeks, you will just find a free time and then you just sit down 1 hour and do the assignment and submit. Okay, any questions so far? No problem, right? And then after this, we will have tutorial as per usual. And then we will come to week 11. Well, then tutorial still will be on. And that Saturday, we will have a quiz too. Okay, and this one is a smaller quiz. It's only on tutorial 7 to tutorial 9. So that means Fourier analysis and some Laplace transform. Okay, so that's on the Prof. Teo's topic. And also for the same topic, we also do assignment 2. And it's due this Sunday. So the rationale is again the same. So we have we study the things, then we go and do assignment, do the quiz. So this will help to reinforce our concepts. Okay. All right. Any questions until here? Oh, looks like no problem, huh? Yeah. Then after that, we will have tutorial until week 13, and that completes the course. Okay. All right. So these are the exact dates. So this is our quiz 1. So this is the day. Quiz 2 is this day. Then assignment 1, as I say, we open it early. So you just find a free slot inside here, and then you do on your own. Okay, this one you can do at home. You don't need to come to school. And assignment 2 also like that. Open for 2 weeks for you to do. And then we have an exam. All right, so this is the day of our exam. So any questions so far?
Just to check, right, your opinion, which chapter is the killer for the usual students, like usually?
Which chapter is what?
The killer topic.
Certain part of partial differential equations. Certain part of partial equations, you will find it not easy to understand. If you are quite good at your study this differential equation in your Maths A, right? Is it called Maths A?
I think we learn a bit like we learn a little bit, like if I'm not wrong. Yeah.
Second order differential equation or first order differential equation.
Yeah, we did that. Yeah.
How to solve first order differential equation, second order differential equation.
Yeah.
You need that kind of knowledge. That means we assume that you have that knowledge, and then we do this partial differential equation.
Oh, I think have, but not memorized only, because there's a lot of methods.
A lot of methods. Yeah, there are a few methods. So we need that in partial differential equations. So partial differential equations, the beginning one is quite okay, I think. But when you go deeper, then students will find it not so easy to understand, because the mathematics is quite a lot. So this one, partial differential equation. And then, okay, let me comment here. Probability and statistics. A lot of students, probability and statistics, actually the calculation is very easy. You just do some integration. Well, I think that's the most difficult integration. Integration also not say integrate a very difficult function, right? So probability and statistics, the calculation, the computation is very easy. Nothing complicated. Then what is complicated then? Probability and statistics is the concept. It's the concept, because if you don't understand the concept, then you don't know what to find, right? Or you don't know how to find. Then like just now, the find probability, right? Should you multiply? Should you add? So these are concept. It's actually concept. It's not the difficulty in go and calculate, right? But it's the difficulty in understanding, knowing what method to use. So probability and statistics is a concept. Concept must be good. Calculation is actually very simple. Then let me talk about numerical methods. Numerical methods, actually a lot of students score in numerical methods. They score very well in numerical methods. Numerical methods actually is quite tedious. It's quite tedious. It's straightforward and tedious. That's what I would describe it. Straightforward and tedious. Straightforward meaning that actually there's no trick one. No trick one, very straightforward one, but it's tedious. So you need a clear mind to do it well. You need a clear mind. Well, that's it all. That's all I can say. It's straightforward, and you need a clear mind to do the calculations. So that's all. That's numerical methods. So therefore, some students, they can do it very well. All right. So then how about Fourier analysis? You may also find Fourier analysis a bit difficult if you are not so good in integration, because Fourier analysis use a lot of integration. So if you are not so good in integration, like integrate sine, integrate cosine, and after integration, you need to put in the limits, manipulate the terms. If you are not so good in this, then we'll make mistake. Yeah, But if you are good in, doing the calculus, and you are quite good at the manipulating the terms, substituting in the values and so on, then it's not difficult lah. So that's Fourier analysis. You need integration. Integrate sine, integrate cosine, put in the limits, shift the terms, and so on. Okay. And then Laplace transform. So now we come to this topic, Laplace transform, right? Laplace transform, a lot of students like, because you all studied before, right? Am I right to say that you all studied Laplace transform
One
before?
semester
We
ago.
have studied Laplace transform before.
Can I say that a lot of you come from Polytechnic?
I
you
think
can
most,
say that.
but I think we remember from uni, not from poly.
Oh, is it? Where did you learn Laplace transform?
Circuit analysis last semester.
Oh, circuit analysis. Well, our Laplace transform here may be more complicated. More complicated than the circuit analysis one. But anyway, because you also learn it in a Polytechnic, then now also circuit analysis. So when you learn it here, although more complicated, but you will also like it very much. Yeah. Is it okay? All right, all. Yeah, okay, all. Well, that's all I want to say about our course briefing. Okay. Yeah. Let me see. How do I? Oh, I see this button here. So I'm back here. Okay. Yeah. So is everybody okay? All right, all. Yep. So if it is okay, then we'll stop here.